Hi everyone. This is the beginning of chapter 3, and we're going to start talking about limits, which is going to be our first topic for this year that's probably going to be brand new to most of you guys, because you haven't learned limits before. So let's start with a notation. This is what a limit looks like. You have the letters LIM, which stands for limit, and then underneath you have a variable with an arrow, and then there's going to be some number. I put A for here, and then after it is some function f of x. Now the way you would say that in words is you would say the limit as, and then you read what's underneath it. And that little arrow, we say the word approaches. So you would say the limit as x approaches a of, and then the function to the right, the f of x part, that's what you're taking the limit of. So we end up saying the limit as x approaches a of f of x. Now what it means when we say to approach in math, we mean to get as close to something as you possibly can without quite getting there. So what we're really saying is what's happening to our function f of x when we get really, really, really close to that number a without quite getting there. So we don't want to see what happens when x equals a. We want to see what happens when x is very, very close to a. So to put some numbers in there, let's say, for example, we were talking about the limit as x approaches 3. So what I might do is, instead of saying, okay, what happens when x equals 3, I want to see what happens very, very close to 3. So I might say, 2.9999, put a whole bunch of 9s in there, and say, well, what's happening right there? That's really, really close to 3. Well, that's close to 3. That's a little bit less than 3. We also want to know what happens when it's a little bit bigger than 3. So I might also ask myself, what does f of x equal when x is 3.000? You got a whole bunch of zeros in there, and then you stick a 1 on the end. So we're taking a look at a number that's just a little tiny bit smaller than 3, and also a number that's just a little bit tiny bit bigger than 3, and we want to see what happens there. Now I want to emphasize, when you're doing a limit, you are not asking what happens when x equals 3. You're asking what happens when x is very, very close to 3. So the first way we're going to look at for evaluating limits is through a table of values, like an XY table. So let's say, for example, in some question, I was trying to find the limit as x approaches 5 of some function, f of x. Well, I might create an XY table that looks kind of like this, where I set up my XY table, and when I'm choosing my XY values, what I do is I choose values that are very, very close to 5 on either side. So like over here on the top 3 values, I picked 3 numbers that were very, very close to 5, and it's approaching, it's getting closer. So I have 4.997, which is closer, which is close. 4.998, a little bit closer. 4.999, even closer. So basically what you're really looking for is you're looking for a pattern. You're saying, as I look at these numbers here, what's happening there as I approach 5? And then I'm also doing the same thing with 3 numbers that are a little bit bigger. I have 5.003, that's close. 5.002, that's closer. 5.001, that's even closer. So again, I'm looking at these 3 numbers and I'm saying, do I see a pattern here? What's happening as I approach? Now notice I didn't put the number 5 in my table, because remember, when you're doing a limit, we're not trying to see what happens when x equals 5. You can put it in there, but that's not the answer to the question. What the answer to the question is, if you look at that red arrow and that purple arrow, what's the pattern as the numbers are approaching 5? So here are the possible answers to a limit question that you might answer from looking at a table of values like that. So number 1, if you notice that both of them are kind of going to the same number, then that number is the answer to the question. And here's an example for that. So let's say, that red arrow on top, I notice it's getting closer and closer and closer to 7. I get like 7.0001. And on the other side, it's also getting closer to 7. I'm getting like 6.99999. Well, because both of those numbers are very, very close to 7, they're basically approaching 7, and that would be the answer to the question. So you don't have to get exact answers on limits. If it's very, very close, to the same number on both sides, that's the answer to the question. Now, another possibility is if it's completely different on both sides. And here's an example. So let's say on one side it's the same as the last example I gave you. You have numbers that are getting closer and closer and closer to 7. It's going like 7 point something, and then you end up at 7.0001. But on the other side you're getting 2.999. It's like approaching 7 on one side and going to 3 on the other side. Well, if you're getting a different number on either side, we say that limit does not exist, and we can write DNE for that. So whenever we have a limit that does not exist, you can write DNE for your answer. The third possible one is if you notice the numbers aren't really approaching something. You're not getting 7.0001, or you're not getting 2.999. You're getting numbers that are just getting bigger and bigger and bigger. When you're here, it's 1,000, and then it's 2,000, and then it's 10,000. And the closer you get to your limit value, the bigger the number gets. And that could be positive or negative. It could be going from negative 1,000 to negative 2,000 to negative 10,000. Then that limit is actually going to either positive or negative infinity, which we'll talk about later in the chapter. But for now, we're going to say DNE does not exist for that one too. And we will talk more about those at the end of the chapter. But for now, a limit going to infinity, we'll just say does not exist. All right, so here's an example. Here's our function, our limit. What we're going to do, we're going to try to answer this question by making a table of values, but we're not going to make the table of values by hand. I'm not going to get a piece of paper and write X and Y and start, grab a calculator and start plugging in, 2.9999 or anything like that. I'm going to show you how you guys can use Desmos to do the work for you, basically. We'll graph this thing on Desmos, and then with a couple extra clicks, we can just type in the X values. It will create the table for us. So let's do that. Okay, so here we are in Desmos, and you guys can see I've already typed in the equation, so you can see the graph, but the graph isn't really what we're looking for right now. What we want is a table of values, an XY table, and I want to show you how Desmos will make that for you. So if you've already typed in your graph like we have here, if you click the little gear symbol right here, this first choice here is convert to a table. So if you click that, it creates a table. Now what you notice is it's not the numbers that we want, but that's fine. We can type in whatever numbers we want here. In fact, I'm just going to delete everything here. So let's clear all this out. So what we decided is we want about 3 numbers that are a tiny bit bigger than 0, and about 3 numbers that are a tiny bit smaller than 0. So what I think I would do, let's start with the negatives. I'm going to go negative 0.003, negative 0.002, and negative 0.001. Now just from those 3 numbers, I can see that what it looks like to me is the numbers are just getting bigger and bigger and bigger. So I think so far that my answer is going to be does not exist. Let's see what happens on the other side too. So on the other side, I would do positive 0.001, 0.002, and 0.003. And you guys can see, remember, we're looking as you approach 0. I didn't put 0 in there. If you want to see what happens when it actually equals 0, you can put that. It's undefined. But remember, we don't really care about that. I'm going to erase that. We don't really care what happens when it equals 0. We're looking for what happens when it's close to 0. So what I see here is if I look on either side, as you're either starting at the top of the list or the bottom of the list, and then working your way towards the middle, which is where 0 would be, the numbers are just getting bigger and bigger and bigger, which means our answer to that question is DNE, or does not exist. So based on what we just saw in Desmos, the answer to the question would be DNE, meaning does not exist. This limit does not exist because as we're getting closer to x on either side, the number's a little bit bigger or a little bit smaller, the values of f of x aren't approaching a number, they're just getting bigger and bigger and bigger. They're doing what we would call going to infinity. All right, to finish out our example, we're going to do these 3 limits. Now, before, it might seem like a lot of work, but you notice it's the exact same function. So basically what I'm going to do, I'm going to go back to Desmos. I'm going to leave the graph in there, leave the table in there, and I'm just going to change those x values. So instead of seeing what happens when we're close to 0, the first thing I'm going to do is see what happens when we're close to -3. And then I'm going to see what happens when we're close to +2. And then I'm going to see what happens when we're close to +1. So it's 3 completely separate questions, but it's the same function. So I can leave all my work in Desmos. I just have to change the x values on my table. So let's go ahead and do that. So we're back in Desmos, and we're going to answer those other 3 limit questions, but we don't need to change our function. Remember, it's the same f of x. All we need to do is change these values in our xy table. All right. So our first limit was as x approaches -3. If I want values that are a little bit, tiny bit smaller than -3, I would probably go -3.003, -3.002, and -3.001. Now the numbers that are a little bit bigger than -3 are -2.999, we'll throw another 9 in there, -2.998, and -2.997. Okay, now when I look at the pattern, you got to be very, very careful here because it looks like it's going to the same number. It's following the same pattern on each side. You have a 37, a 55, 111, but on one side it's positive and on the other side it's negative. Those are different, so no matter what, the answer is going to be DNE again. So the limit as x approaches -3 does not exist because it's positive on one side, it's negative on the other. It's not going to the same thing. All right, the second one was +2. Clear these out again. Positive numbers are a little bit easier to get close to than the negative. The negative was a little tricky because, a number that's smaller than -3 is 3.01, and a number bigger is -2.99. A little easier with positive numbers. So what I would do here is probably something like 1.997, 1.998, and 1.999, and then 2.001, and 2.002, and 2.003. And now I definitely see a pattern. What I see on both sides is numbers that are getting close to about 0.05. If I look the closest on one side, I get 0.05006, and on the other side, I get 0.0499. We're getting very, very close on both sides to 0.05, and that's going to be our answer to the question. So for that second limit question, the limit as x approaches 2 of this function, the answer would be 0.05. So one last question. That was the limit as x approaches 1, and I think what I can do is just do this. Take these 1's out of there and change these 2's into 1's. And it looks like we get an answer again. Same thing, we are following a pattern. So I think we're going to have the case here where we end up with 0.25, or it would end up being 1/4 if you wanted to write it as a fraction. But 0.25 is fine. When you're using the table of values, it's perfectly okay to answer as a decimal. And I think that's our answer here. So basically we have 4 separate limit questions from the same function. It depends on what x value you're looking at. We looked at when x is close to 0, and we said we're not getting a limit there, does not exist. We looked at when x is close to -3, same thing, does not exist. Then we looked at when x is close to +2, we did get an answer, it was 0.05. And then we looked when x is close to 1, and we did get an answer again, and it was 0.25. All right, so that's our first day on limits. We're going to spend a lot of time on this. But I hope you guys understood this. I hope it makes sense. Try the assignment, and we'll go over it tomorrow.